John here. Let's talk about Git. Let's start with why do we want it, okay? In the simplest of terms, this is how software development works. You start over here. You edit a bunch of code. You build it, compile it, build it, whatever term you want to use. You then run it and you ask, does it have any problems? If it does, you go back and you edit it some more, you compile it again, you run it again. Has it got problems? Yeah, you keep on going around and around and around here. Sometimes you never get out of this loop, which is unfortunate. Once there are no problems, or at least, it's good enough, you can cash in. You declare it done, you have a release, and you make the big bucks, all right? What observations can we make about this? Okay? What you're going to be is a couple of things here, right? You're going to go around this loop at least once, if not 1,000 times, before you get up down here, all right? So what we need to do is optimize our efficiency in these steps here. This step does not need to be optimized because you've got 1 trillion people on the planet that all want to do this, and they're clamoring for this. A lot of those people cannot do this part of the work up here, right? The programmers are different than the salespeople. Okay, so we programmers need to optimize this, all right? Minimum headache for ourselves. So there's a certain set of techniques, styles, and approaches and how to think about stuff that can make our lives a lot easier. Let's make some observations here. What is code, right? For our purposes, these are files of text. And when I say text, I mean, raw text. These aren't Word documents and things like that. These are very simple, low level, 9 times out of 10, these are ASCII files. Dot my I there, okay? That's what this is. Lines of text in a file. No more, no less. Compiling and building. To do this, we need to write scripts or use make. Okay? To run it, more than likely, you need to have a script for that too. What are these scripts here for? These are here to automate the process. Okay? The more we can automate, the less time it takes us to do our job. Of course, we don't want to automate our jobs completely away. That would be silly, right? Well, it turns out this one here is kind of a tough one to automate away. Maybe someday, but right now, not so much. So we can spend almost all of our time editing code, right? Then we run a little script to build it, run a script to run it. In fact, quite often this can be combined, right? If we're good, if good, okay? Once again, we're back to here. What does it mean to edit a file? Right? You have like a file. You could start with nothing, right? Then you start typing text into it, lines of text into it. Then you have, something. File, run, It might even be, one could argue there's another loop in here that looks like this, okay? This loop might even get done more often, right? Sometimes it won't even compile, so you can't run it. So you have to actually loop around in here. But that's just a side observation, okay? Just for yucks. Because, yes, we live our lives very much in this tight little loop over here. All right, so what's the point here? These are text files. What we need is a set of tools that makes the long-term management of these text files easy on ourselves, okay? What happens? Quite often you have a program, it worked yesterday, but it doesn't work today. Well, there's question number 1. What changed? Okay? Did I add a line of code? Did I delete a line of code? Did I change some initializer? That's hiding in here. So how do you answer those questions? So to answer the question of, how did it break, right? How did the program break from yesterday to today? How do you answer that question? Well, if you save backups, you might have the old version of a file, and now you have the new version of the file, and you can look and see what's different, right? So let's call this yesterday's version of my program, version, 1. Okay, so this is like yesterday, or an hour ago, or whenever prior in time to now. Okay. Let's say we now have version 2 of the program, right? That's now. How do I know what's different between 1 and 2? Okay. Some of you may already know there's a command called diff. Very useful command. But the value of diff depends very much so on how you created your source code files, right? So this will depend on how the style of your source code. Okay? And by style, you'll see that as we go through today's discussion. This is really important. A lot of people ignore this completely, and it makes much trouble for people that want to use this diff command, all right? And what we'll see is diff is the kind of the heart and soul of Git. Okay? Git is a way to manage diff. Plain and simple, all right? And then a lot of things build up on top of that, all right? So let's look at what it means to have a file, an old file and a new one, and how diff is used on it. All right, so let's say we want to write a new program, and we're ready to go here, okay? Obviously, I forgot the pound includes, IOStream, and the namespace stuff is missing here. But, this is actually the kind of mistake that's commonly made, right? So here I am. I made a file, and I want to test it out. Let's try compiling it, okay? What happens? Uh-oh, there's an error, okay? Let's fix it. And we're geniuses. So we're going to do this. Okay, oh, I'm so smart, I know what I'm doing. Oops, no, I didn't. I remembered to include the file, but I forgot that I have to put the std : in front of there, or I got to say using namespace or whatever. I could be very lazy and do this. Generally, I don't do this, okay? Nor you should do this, right? You should say using cout, right? Because if you use the entire namespace, you have no idea what words you just changed the meaning of in your code. Trivial code like this, just using namespace std will work, but doing this tells me, look, I only want cout and endl, so that it could be another 100,000 lines of code down here. We do not want to change the meaning of things down there, right? So let's try and compile it again. Okay, this time it worked. And because I use the simple compiler command like this, what is it really doing? Well, by default, it's going to name the executable program a.out, because it didn't tell it what to call it, right? And of course, it works. Hello world. Great. That's my first version. And what did I do? I added a file. I built it. It failed. I edited a file again. I built it. It failed. I edited it a third time. This is like the third version of this file. Finally, it works. And what are you going to do? Well, if I'm a good programmer, I'll make a backup of this thing. Let's call this one version 1. All right? So what do I do now? I got 2 files. I have a thing called version 1, and I have the current one, what Git will call the head revision. Okay? This is the head or the head node. As we'll see, Git thinks of all these files that we're going to make backups of as a linked list. This is version 1. This is the head. Okay? So if you think of this is a linked list. The head of the list is here. The previous version is version 1. It's right here. Okay? So let's go on and make some more changes. All right. I don't want a hello world. I want a hello John. Yeah, I'm obnoxious. I just want it to talk to me. All right? So let's compile that one. Okay, let's make sure it works. Woohoo! Works great. Awesome. Copy this over, now to version 2. Make another backup and name the files right. All right, there we go. Version 2. Awesome. So what do we got going on here? If you do this, And in a real program, obviously you'd be making more changes and stuff like that. What do we really have? Here's your head. What's the previous version? It's version 2. What's the previous one to that? Version 1. Okay? So what do we got going on here? What can I do with all this stuff? Well, let's observe what's happening here. The head version, the last time it was saved, was at 704. Okay? This version here was created at 704, 1904. This one here was 1 minute earlier. They're all last touched or created by this guy Winans over here. Okay. What's the difference between this head node and version 2? There's no difference. What's the difference between the head node and version 1? Aha. This line of text here, this little less than sign, represents the argument on the left. Diff, the two files. The left file says, in the left file, I see this line of code that is different and does not match the same line of code on line 7. Oops. In the file on the right, there's the right, the greater than sign. The file on the right has this in there. There's the difference between this file and the other one. Everything else in the file is the same. Okay, that's kind of cool. Very useful. So what does Git do? Git saves all these different versions and allows you to ask it, what's the difference between this one and the previous one or the one from an hour ago and stuff like that. What else does Git let you do? Beyond this, right? I mean, you could just do this, but you'd have this clutter of files. You'd have to manage them all yourself, and you don't know why any of these changes were made. Okay, and it's trivial and obvious example that I'm doing here. It's easy to figure out what the motivation was between these two things. But obviously, when you're doing a real program, you're adding subroutines, changing math. You could be doing all sorts of stuff in there, and it's not necessarily obvious why you did it. Or it might be obvious if you want to look through, 900 lines of differences between the two files. All right, textually, the differences might be many, many, many different, lines of stuff in here. And you'd have to go look at every one of them and think about what the heck is that? What does it mean? Especially if you did it 3 years ago. I forgot why I did that. What was that? Well, put a message in there. Put a note to yourself in there. Why did you make that change? And make the note meaningful. All right? So Git allows you to do these things. It does a lot more as well, but in the most simplest of terms, it lets you save all these different versions. It lets you ask which ones are different from each other and what are the differences, and summarized like this in other ways as well. What else does Git do? It puts all of these differences in a database, okay? This is a repository. Okay, or most accurately, it's a Git repository. Nobody calls it a repository, by the way. Everyone calls it a repo, okay? Only the new guy is going to call it a Git repository. Repo, okay? That's an R. Repo, okay? So this is a repo. All right, what's my point? Well, this is where it fills up with all these diffs of your files, okay? And it remembers all their IDs, like version 1, version 2, version 3, and it remembers all the little messages that you can affiliate with each version and say, this is why I made the changes I made, okay? And I'll show you how to do all that in a minute. Now, what's my point? Git lets you make copies of these repos. And the command to make a copy is called clone. All right? I can clone a repo. In fact, once I've done it, I can do it again over here, right? If I want to. All right? We're not that concerned about this. That's more advanced stuff, okay? So yes, this is how it works, just so you keep it in mind, but I'm going to X that off. Not going to get into the details of how that works. We're going to stick with this. Why? Because we are going to do this, right? What's the difference between what I just X'd off and what this thing does. Well, one of them is got multiple hops along this path. This one over here, one could observe is transitively dependent or derived from this one over here, okay? These two repos are both directly descended from this, okay? Now, for our purposes, okay, this guy is going to be called the origin server. These are all Git words, okay? Now, it turns out if you did have this other repo over here, let's just call this X. This is the X repo, okay? From the perspective of a repo like this that's, been cloned from a clone, its origin is here, okay? Unless you do something to let it know otherwise. It doesn't have any idea that this is over here, right? We don't want to think about all this stuff, okay? Keep it simple. We're going to create a repo somewhere. We are going to declare it as the origin. We're going to use this as the origin for as many repos as we want to make by cloning the origin repo into some other repos, okay? And what we're going to do here, just so you see where we're going, we're going to put this on our local home PC, okay? We're going to put this one on Hopper, all right? Now, why do you want to do this sort of thing? Well, let's do a homework assignment. What does that really mean? Maybe I want to do a bunch of development, typing and stuff and testing if you can, if you got a compiler and stuff on your home PC. So you don't have to log in over the internet. Maybe you got a slow internet connection or something like that today, and you don't want to have to log in to Hopper or go to a friend's house or whatever. Just do your work on your laptop, okay? You can do that. You keep putting your modifications over time into the repo on your PC. Your home computer can have all this stuff on it all on its own. When this is all ready to go and you think it's work, you might want to hand it in. You're done with your assignment, or in the real world, you'd want to share it with your coworkers or publish it to the world or something like that. What do? You need to push, we say, your repo back up to the origin. So you clone it once and only once to get the copy of the origin down to your PC, okay? And this is where you're doing that tight loop. Edit, build, test, put it back in the repo, okay? We call that committing, right? So you're going to edit, and compile, build, run, test, and all that stuff. And then you're going to commit while you're doing your changes. And this is great because it backs up all your work, right? Sometimes you start making changes and you go, oh, this wasn't such a good idea. I really wish I had it from an hour ago. Well, if you commit each, significant step forward as you converge on your solution, you can go back and get it. It'll be great, okay? Now, when you're totally happy, you push it back up here, all right? That's when you push it up. You can also push it anytime you want, okay? But at least when you're done, you want to push it back up here, all right? And these two repos, when they're first cloned and when you're pushed back up here, they're exactly the identical copies, okay? All the code is the same. So what happens? Why do I got another one down here? What's the point of this? Well, remember, you have to hand it in a condition where we know it runs on Hopper. So what you're going to do, what I would do, all right, clone your repo for your homework assignment. That's going to be how this works in this course. We're going to give you an empty-ish repo or, primed up with some, test files or something. You're going to clone it down here. You're going to do your homework, commit, push back up here. Then you're going to log into Hopper. Because these two are the same, you can clone it a second time. Go ahead and clone it down here. Build, run, test. Hopefully it'll work. But maybe it won't. What are you going to do? Well, you have two options. You can edit your files on Hopper. Build, run, test, build, run, test, build, run, test, edit, commit them back in here, and you can go and run the loop down here. And when you're done with all that, he too can push up here, all right? If he wants to, okay? That's one way to do it. The other way to do it is if this fails, ignore it, go back to your home PC, do your modifications here, testing, building, and all this stuff, commit, push it back up here again, go back over to Hopper, and you have two options. You could throw this whole thing away and start over and do another clone, right? I mean, it'll give you the newer version, clone the new one, okay? And I know a lot of people that actually work this way, so that's viable, although that's not, you don't want to do that. That's for people that are not software developer professionals, okay? Normally what you would do is you'd know that you had already cloned it once before, okay? Rather than just deleting it and cloning it again, what you can do is you can use another command called pull, okay? So let's put some numbers on here. Clone. This happens once and only one time, okay? That's what gets the first copy down here to Hopper. Clone. Once and only once. That's what gets the initial copy onto your home PC, okay? If you go back home after you've cloned and failed on Hopper, okay, and you want to edit up here, commit, push it back up, you can go over to Hopper and say pull. It says you've already cloned it, so I'm going to pull. Why do you do what's up with all this? Well, over the course of time, if your software becomes bigger and bigger and bigger, it could become megabytes and gigabytes of data. You don't want to delete everything and start over every time. It could take forever to pull that, to clone it, right? So if you type pull, what it'll do is it'll do an optimized transfer. It'll actually just go up here and get the last diffs that it does not yet have and go a lot faster, okay? Now, for small programs in this course, you could just throw it away and start over each time. And that would work, but learn how to do it the right way. Clone it once. And if somebody else pushed up here, even if it's yourself, from some other place, you can pull them down. Pull, all right? You can also do it the other way around is where I'm going with this. Let's say you're on your PC, you build your stuff, you commit all your stuff in here, you push it back up here into the origin, and you log into Hopper, and the first time you do your clone for the first time, doesn't work. Edit, commit down here. When it all works and perfectly down here, you can push it up this way. You go back home, you do the pull to your house. Okay? Once you've done a push from here and a pull down there, all three of these repos are synchronized. Okay? There are ways to communicate directly through here, but that's advanced stuff. It's sort of like doing this. All right? You want to learn that? Go read all the manuals. I'm not going to talk about that. What's the whole point of this entire lecture so far is treat one as the authority. We call that one the origin. This one we're going to put on GitHub. Okay? You're going to clone that as many times as you want. And then you have to keep your mind, clear on this. So if you make a bunch of edits up here, you're going to want to push them up here, and then you're going to log into Hopper and pull them down here to keep these things synchronized all the time. If you're totally sloppy about all this, what can happen is you could clone to your home PC, you could clone to Hopper, you could do some edits here, you might even do the commits up here, you could do some edits down here on Hopper and commit down here, and now we have 3 different versions. Okay? And what would happen if you ended up in this situation? Well, one of these two could push back up to the repo up here, because what they've done is it has diverged from the repo, and the repo doesn't, the origin, I should say, the origin repo doesn't know anything about these, that you've done all those commits until you try to push them back up here. So let's say they both try to push, okay? Whoever pushes first, no problem. The second one that pushes in, it's going to say, hold on there, Hoss. You're trying to push something up to a repo, but somebody else snuck in modifications, and I can't just take yours. Because what was it going to do? Is it going to override? You're going to just delete this other guy's changes? I mean, in theory, that might be what you want, but that Git prevents you from doing that sort of thing. Okay. And what Git will then do is it'll say, look, if you want to push your stuff up here in a scenario where somebody down here pushed up before you did, what you can do is you can ask the origin server, you can do a pull and merge your modifications with this other guy's modifications to end up with a superset of all modifications in one big wad. Then you can take that and push it back up here. All right, are you following me where I'm going here? Let's draw a diagram. So in the scenario I just described, it's very common to draw these diagrams up in Git, right? So what do we got? Let's draw the 3 different repos over the course of time. Here's your origin. Okay. Here's your PC. And here maybe is Hopper. Just yet another machine. Okay. So let's say we provide you with an existing project, right? Creating the initial repo is effort in itself. You can read some tutorials on how to do that if you really want to know. That's not what I'm going to talk about in here. This is about, let's say something already exists. What do we do? How do we modify it once you hit the ground running? Okay, so let's say this thing has version 1 and that it has been modified to version 2 and so on. Okay, what happens here? If I clone the origin at this point in time, what I get is everything that's there. Version 1, version 2. Let's say I log into Hopper at this point, and I do the same thing. I clone it. I got version 1, version 2. And what I'm drawing up here is a linked list. Version 1, version 2 is from version 1, right? It's modified and then pushed up, or rather committed into the Git repo, okay? All 3 of these are in sync at this point, right? So what were we talking about? Let's say he creates a version 3 here. And he goes, oh, I want to push that back up to the origin. Okay, no problem. The origin says, your entire history up to this point matches mine. And I'm going to just take this right here. If this guy, on your PC, if you say push, it's going to take this version 3 and it's going to tack it on over here. Okay? Now let's say this guy on Hopper also edits a file and he commits it. What really happens here? Is this version 3? No, it's not. You're going to find out that Git names these versions with really gigantic, giant hexadecimal values. Statistically, every single time anyone commits anything into a Git repo, it will always get a unique version ID, even if it's on a different box. Okay? So technically, this would be like version 4. Okay? My point is, don't worry about the fact that, this guy doesn't know and he's going to create a version 3. No, he won't. Okay, we'll look at these IDs in a minute. They're very big, gigantic numbers that are unique. Each server will create a different set of numbers. Okay, so my point is that issue is solved in how Git works. All right, so what was the problem here? If this guy here wants to push his stuff up to the origin's going to say, all right, great. I'll look at this push here. And I'll say, okay, this looks good. That looks good. That don't look good. You're going to get an error that says you need to merge version 3 here in with your version 4 before you can push your stuff into the origin. All right, so it's going to say no. So what do you do at this point? You do a pull. And this version 3 comes down here. And what happens is, the version, let's call this one version 5, because what it's going to do is it's going to take version 3 and do what's called a merge with your version 4 and create a version 5. Okay? At this point, Git will remember that this thing here was a merge of 3 and 4, okay? And it'll put the version 3 in here in his repo. The point is, That way, he can do a push over here, okay? All right, bear with me here. And why is this important? It's because if he does a push, the origin is going to say, okay, these two match, these two match, these two match. Now I've got this stuff over here. I can take it, right? So he's going to end up with this version 4 over here, and he's going to end up with a version 5. This thingy here is called a merge, okay? And this will have been saved up in the origin. All right, now this goes on forever. If this guy creates a version 10 over here and tries to push it, then he'll have an error, and the exact same thing will happen. So what's the takeaway here? Well, every single time you push something up to the origin, go to all your other repos, in my opinion, right away, if it's reasonable to do so, and pull these down. Don't forget to do this, because sometimes these merges don't work so well, okay? And you have to do a lot of work to fix them, all right? You have what's called a conflict, and we'll see that soon enough, okay? So if this guy does a merge and a push up to here, and then you log onto your PC, you can pull it back down. What's my point here? If you think this out, reason it all out in your head, it should be obvious that all these issues can arise, and Git provides a way to resolve them. In your life is a lot easier if you keep each one of these things if you're going to edit in more than one place, right? This can only really happen, right, if you edit in both places at the same time. Or if there's two people editing the same files at the same time and stuff like that. Anyway, my point is, as long as you keep these things relatively synchronized all the time, then this notion of merging and stuff, it either never happens because you do everything orderly in a way that makes perfect sense, or the merges are very small and easy to take care of. All right? Now, if the world was a simple place, we'd be done and ready to go, and we'd start working. But it's not. Okay, so what we need to look at one more thing before we dive in and start using Git. I feel like Columbo, right? You know that character, what is he? He's like a detective or something, and every time he walks out of the room, he always says, but there's one more thing that bothers me, right? So I always refer to what I'm doing to you right now as Columboing the conversation, right? Because, oh wait, one more thing, all right? And that's this. This is one analogy. The same concept applies in many different ways. But in this analogy, what's really going on here? Let's say I've gone through my fun and games and made many versions, and I'm all ready to go, and everybody's happy. I make release. Release number 1. Right? There's going to be another release in the future. Of course there is. Why? Because you sell, maybe 10,000 copies of your software. Maybe that's the total number of people that'll ever buy it. Are you done? You go out of business? Heck no. You add a few more features, and then you sell the upgraded version of the exact same program that everybody already owns to the same people again, right? You have no better customers. Somebody who's already bought a pen, send them another one, right? Okay, I joke, but as consumers, we know this very well. The newer version's better than the old one. Maybe it runs faster, it has more functionality or whatever. Point is, how does Git deal with all this, right? Now, on the one hand, you just have, okay, after, 50 commits, maybe I release it, and then do another 50, and then on number 100, release it again, and so on. If the world was that simple, great. But it's not. What do we really need to do here? What we need to do is deal with the fact that once we've made a release, okay, let's say we have release 1, and then we're iterating in here. Uh-oh, there's a bug. There's a bug in release 1. Meanwhile, we've made 50 commits into our repo since we've made that release. What do? We need to go back into the repo and find the version that release 1 was made out of, and we need to be able to edit that release 1 and come up with a release 1.1. We'd like to do this without messing up all the new modifications that we've been doing to come up with release 2, right? So what happens is these linked lists, right? This stuff that we were looking at like this, it's not so simple. these linked lists fork. Okay? They're not lists at all. They're trees. Okay? And trees have branches. And I say that because this is the branch is a Git term, right? So let's look at what happens to handle this situation, okay? Once we got this, we got it all. So here's my origin again. Version 1, version 2, version 3, okay? Was I drawing the arrows like this? I probably, Git looks at this actually as kind of a doubly linked list. So I've been putting arrows in here. I probably shouldn't have done that. Okay, let's just do it like this. Okay. Version 4, maybe like that. Okay. Let's say this is my release 1. Okay. I'm going to just mark that over here. And when I'm done with that, I want to go on to version 5, version 6, version 7. So you're going to have another release over here, release 2. Okay. And over the course of time, this just goes on forever. Okay. Right? And you just keep developing your software. Let's say we're in the middle. Let's say the current time is, over here somewhere. And somebody that has a copy of release 1 notices this bug. Remember, this is about bug fixes. And I got to go back and fix this. Well, one thing you could do is, you just buy version 2. And maybe that'll work, but maybe it won't. Maybe they really want to buy a bug fix, or maybe you owe them that bug fix. Because sometimes you sell software, you say, I'm going to guarantee that I'll support this if you need to use this for 2 years or something. And you're way over here and somebody's still running this old one. You got to go back and fix it for them. What do? Well, what you do is you put a node over here. Remember, this is a tree. And the way a tree works is it branches. There's going to be forks in these paths, Maybe this is going to be version, 105 or something like that. Now, maybe you even have a version 106. While you're fixing this bug, you have many attempts, right? It doesn't compile, or it looks good, but then it fails, and now we got a 107. Oh, it took you 3 tries. It took 3 commits to fix this thing. Maybe this is version 1.1. It's based on this. Okay? While all you and everyone else are still developing along this branch up here, this is a bug fix branch, okay? Okay? Sometimes these are called hot fixes. The only difference between one and the other is just how important it is to you, okay? All these are branches, okay? Same thing could happen down here. While this is going on, you could be working on version, release 3, and there could be a bug on release 2, and you end up building things over here and so on, all right? So this is what you start to see happening in your repo, okay? Now, this is great if these can just dead end like this. Your life stays simple. You're going along here. But, again, life is not so easy. What really has to happen, this is a simple scenario, go back and fix an old one. The same situation happens when many people are trying to contribute to the same project at the same time. And you end up with stuff that looks like this. All right? Or you could. Okay? Now what happens? Well, let's say this is John's branch. And this is Jim's branch. And so on. Could be many people doing stuff in here. Eventually, I may be developing stuff, and I want to make it available to everybody else. Okay? What do? I need to merge my stuff into this master branch. Okay, so let's just say this bottom one here is the master. The purpose of this master branch exists solely for me to create a branch up here, do a bunch of modifications. And when I think it's good and I want to contribute to the community, I'm going to say I need to merge my stuff back into the master. And I can do that while Jim is still doing his own thing. And when his stuff looks good, he can move his stuff into the master. All right? And this can go on for many, many people. So let's look at a closer view of this kind of a diagram here. All right, after all, this is the superset of the, maintaining a release kind of a situation, right? So you got a master. Maybe this is your initial version. And we want to release a piece of code. So what happens is, okay, so I'm going to do this. I'm going to create a branch. Here's John's branch. I call this one John's development dev, okay? And maybe there's a Jim div, all right? And we're both going to branch from the same place, okay? We start committing. I'm working on maybe, some set of subroutines. Let's call this the blue part of the application, and he's working on the green part. I mean, in an abstract sense. Optimally, we would be working on different parts of the bigger system, is the point. Each one of these things here is a commit that Jim does on his own development branch. Each one of these things here is a commit that John does on his development branch. When John's done and he wants to share his code with everybody else, what he does is he merges it back into the master branch. Right there. Okay? When Jim's working a lot over here and he's done, he wants to merge his in with the master branch. What does he need to do? Look what's going on here. This is a, kind of a two-dimensional version of what happened over here with the merging, right? So Jim's ready to go. What does he do? He has to do this merge. So what he's going to do is he's going to pull and merge. Now, this might take a lot of work because you can end up with conflicting stuff. We may have edited the same code in different ways, all right, which can make this a complicated process. That's why when you're doing this sort of thing, it's nice to have one person working on different files or different parts of the code than somebody else so that this merging is easy, all right? Sometimes it's not so easy, is my point. So he's going to then create a merged thing like we described earlier. Then he's going to merge that back into the master. Okay? Like so. Now, while this is all going on, John can still be doing this. And then he might want to merge in here. What does he need to do? He needs to come over here, bring this up, create a new version here, and put that one in like this. All right? Now, this is a fairly complicated thing, but if you think about it for a little while, this is really what has to happen if multiple people want to work on the same system at the same time. Well, all this is happening. This might be where your release 1 is, okay? And there might be a bug fix going on here, okay? This might be release 2 with a bug fix, all right? These generally dead end, right? These go on forever. This branching and then merging back in, and branching and merging back in, okay? In a real development shop, this is what's going on. Okay, so this is just to make sure that we all understand what's going on, or the motive behind all this branching and merging. Okay, this was the ultimate application of that. For CompSci 340, all we got to worry about is this. Oh, I need to make a branch. Okay, this is you doing your homework. Okay, when you clone a repo to do a homework assignment, the first thing you're going to do is create a dev branch. And when you're done with all this, you're going to commit this back into GitHub. And what you're going to do is you're going to propose at that time that this take place, all right? What you want to do to hand in your homework is essentially just merge this thing back into the master, okay? This is your master. But we're not going to let you do that, okay? You're going to act as though you're not allowed to edit the master. You make a branch, you do your work on the branch, and what you're going to do is you're going to tell the TA that your branch is ready to be graded. You're handing your program in. How does this take place? Now, this is the first time in this conversation we're going to step aside and talk about something that's not Git, okay? This is GitHub. What's the difference between Git and GitHub, all right? GitHub has more features, okay? So what you're going to do is create what's called a pull request to hand in your homework, right? Hand in homework. How do you do that? You create what's called a pull request. Okay, so what does that mean, right? That's not a Git thing. But what you're doing is you're asking the person in charge of the master branch to pull your dev branch, your modifications in your dev branch, into the master. Okay? We're not going to allow you to push it into the master. And we're not going to allow you to go over to the master branch and pull it in yourself. You are going to ask someone else, okay? Someone else who owns the master branch to do the pull on your behalf, right? Someone else owns this. You own this one down here. This is how GitHub really works. This would be like an open source project, right? If they let anybody just shove anything they wanted in there, it would never work, right? People, some mischievous person would just be committing garbage and pushing it into their repos. So this is, the TA owns this branch, and then you own a development branch, okay? So the way this works is we're allowed to see your branch, all the code in here, and we allow you to see our branch up here. We let you see the master. You let us see your development. When you create a pull request, what you're really doing is you're asking us, please take this, because I'm letting you look at it, and do a pull and merge it in to the master. Okay? That's how we're going to hand in our homework. Now, with all this in mind, we can take a step back, go grab a cup of coffee, come back in a minute. In the next video, we're going to do your first assignment. We're going to actually go through this process. We're going to clone the repo for an assignment. We're going to create a branch. We're going to commit some stuff. We're going to create a pull request to hand it in. And then we're going to push that whole thing back up into the GitHub repo like this. All right? Thanks for watching. See you next time.